Look at the digital infrastructure of the modern world. Your phone, the server hosting this video, the global banking system, the complex web of satellites orbiting the Earth. Almost all of it runs on a single foundational architecture, UNIX. But UNIX was not built to change the world. It was built as a joke, a stripped-down, scrappy rebellion. A rebellion against one of the most spectacular engineering disasters in history. This is the story of a $50 million machine that was too perfect to survive. It was a system designed by the brightest minds of the 20th century. It was built to do everything, and it inevitably collapsed under the sheer, crushing weight of its own genius. In the early 1960s, computing was a physical, deafening experience. Giant mainframes lived in climate-controlled sanctuaries. They were attended to by operators in pristine white shirts. You did not type a command and get a response. You painstakingly punched holes into stiff paper cards. You handed your stack to an operator. And then you waited. If you made a single typographical error, you would not find out until the next day. That is when you were handed a printout of a failed run. Computers were simply too massive and far too expensive to be tied up by one human typing at a keyboard. But the world was accelerating. The space race was underway. The demand for computational power was exploding. The bottleneck was no longer the machine. It was the method. Engineers realized a critical fact. A computer processes information millions of times faster than a human can think. If the machine could just switch its attention between multiple users in a fraction of a second, something amazing would happen. Everyone would feel like they had the computer entirely to themselves. They called it time sharing, and it sparked a vision so radical it threatened to upend the entire technological landscape. In 1964, an unprecedented alliance was formed. The visionary researchers at MIT, the telecommunications empire of Bell Labs, and the manufacturing titan, General Electric, they all joined forces. Their goal was not just to build an operating system. They wanted to build a computer utility. Imagine plugging a terminal into your wall. You would receive computing power exactly the way you receive electricity or water, always on, endlessly scalable, and available to anyone, anywhere. They called it Multics, the multiplexed information and computing service. It was to be the final word in software architecture, the ultimate machine. To build a digital utopia, the architects of Multics had to invent concepts that had never existed before. They introduced the hierarchical file system. This was the idea that data could be organized into folders, branching out like a tree. If you use a computer today, you are interacting directly with the ghost of Multics. But a massive problem remained. How do you let hundreds of people share the exact same machine without someone accidentally crashing the entire system? Or worse, stealing someone else's data? The answer was hardware-enforced security. It was visualized as concentric circles called protection rings. Imagine a heavy steel bank vault hidden within another bank vault. At the center, in Ring 0, sat the core of the system. The outer rings housed user programs. If a program in Ring 4 catastrophically failed, the blast doors would hold. Ring 0 remained untouched, and the machine survived. Armed with this brilliant architecture, the team began to build. But they did not want to write in the cryptic, low-level assembly code of the era. Instead, they chose to write Multics in a new, complex language. It was called PL1. It was an audacious choice. They were trying to write the software of the future using a language that barely worked on the hardware of the present. As the months turned into years, the scope of Multics expanded. Every brilliant idea was included. No compromise was accepted. But perfect engineering has a fatal byproduct: weight. The system grew heavier, increasingly complex, and alarmingly slow. By 1969, the dream was suffocating. The General Electric mainframes simply could not handle the sheer mathematical density of the Multics code. The machine designed to effortlessly serve hundreds of simultaneous users could barely muster the strength to support a handful. Millions of dollars had been burned. The timeline was shattered. There was a growing friction between MIT's desire for academic perfection and Bell Labs' need for a functional, usable system. That friction finally reached a breaking point. Bell Labs management looked at the sluggish, bloated behemoth they had helped create. They cut their losses, and they walked away. The Golden Alliance was dead. Back at Bell Labs, two exiled Multics researchers found themselves without a project. Their names were Thompson and Dennis Ritchie. In a dusty, forgotten corner of the facility, they made a discovery: an obsolete, discarded PDP-7 minicomputer. Frustrated by the staggering over-engineering of Multics, they decided to try the exact opposite approach. They did not want a system that did everything perfectly. They wanted a system that did a few things reasonably well. They stripped away the layers of complexity. They discarded the impenetrable security rings, and they built a scrappy, lightweight, incredibly fast operating system. As a playful jab at the massive, multiplexed beast they had just escaped, they gave it a name. They called their little system UNIX, uniplexed, a system of one. UNIX spread like a virus. Because it was simple, it was highly adaptable. It became the bedrock of the internet, the foundation of Apple's operating systems, and the hidden engine of modern infrastructure. But what happened to Multics? The brilliant failure did not actually die. General Electric's computer division was sold to Honeywell, and Honeywell slowly wrestled the sprawling code into submission. Because of its impenetrable protection rings, Multics found a home. It found a home in the one place that valued extreme security over speed or cost: the Pentagon. It quietly ran classified defense networks and military systems for 3 decades, locked away in the dark, entirely eclipsed by its rebellious child, UNIX. The final running Multics machine was not shut down until the year 2000. The story of Multics is the ultimate technological paradox. It is the story of Icarus, written in millions of lines of code. Its creators saw the future with absolute clarity. They designed concepts so advanced, they are still relied upon half a century later. But in their pursuit of the flawless machine, they forgot the golden rule of engineering. A perfect system that does not run is fundamentally inferior to a flawed system that does. Multics had to fail. It had to be crushed under the immense gravity of its own ambition, so that, from its ruins, the modern digital world could be born.